Hello and welcome to Diplomatic Derivatives. In this series of lecture, we talk about applied mathematics. In our previous video, we dealt with scalar product of vectors, also known as the dot product. Today, we're going to talk about the cross product of vectors. So the link of the previous video is in the description box or the I button above. Make sure you check that out as well. Now we talk about the next topic. So let's see what is cross product of vectors. The cross product of two vectors a and b in 3D space is a vector given by. Now before we move on to this, just a quick recap. The dot product basically is the scalar product, basically means that when you find the product of two vectors, the resultant is a scalar. Okay, that is why it's known as a scalar product of vectors. So in that we had two vectors a and b. So a dot b is gonna give us a scalar quantity, okay? But here we are having same two vectors, but those two vectors are of such type that the product of those two vectors is going to give us a vector quantity itself. So in terms of scalar, it means that it's just a quantity without direction, but in terms of cross product, we're going to get a vector it means it's going to have a direction. Okay, so in cross product, we write it as A cross B is equal to magnitude of A into magnitude of B into sine theta n. N here is a unit vector, which shows the direction of this resultant vector. Okay, remember in the scalar product, it was A dot B, which is equal to magnitude of A into magnitude of B into cos theta. In place of cos, we are going to have sine theta. Also, since it's a vector, so it's also going to have a unit vector. Alright, and the direction of this vector is also what we need to find out, and we'll see in the upcoming slides how do we do that. So here this a and b are the magnitudes of the vectors. Theta is the angle between them, again from 0 to 180 degrees, and n is the unit vector perpendicular to both A and B, determined using the right hand rule. So you'll also be seeing how to apply the right hand rule in order to find the direction of this resultant vector, which is basically this unit vector, which is perpendicular to both A and B. Okay, the result is a vector. Again, make sure you remember this. In scalar product of vectors, we get a scalar as the product, and in cross product, we get a vector. Okay, now we're also going to see the component form. So similarly as in the previous one, we had the two vectors. We have vector A is represented like this, B is represented like this. So in component form, how do we write it? We have to make a matrix form, determinant form. Okay, so we write ijk on top. Then we write ax, ay, az, that is the values of A. Then of vector A on the x-axis, on the y-axis, on the z-axis. And then in the third row, we are going to write bx, by, bz. So the values of vector B on x, y, and z. And how do you solve this then? It will be equal to aybz minus azby I minus axbz minus azbxj plus axby minus aybxk. Now at first you'll be like, what is happening here? But the concept is simple. What you basically need to do is, when you have to solve in the component form, first whatever the vectors are given to you, you make them in the determinant form. After making it like this, this is the format in which you're going to solve it. So first one is aybc. Basically you're dealing with this part first, which is here a by bz. So ay into bz minus az into by. Okay, then in the second one, and then in minus in the middle, and then you're going to have ax bx and az bz is what you're going to use. So it's going to be ax into bz minus az into bx. Okay, with j, of course. The first one was with I, then with j, of course, and then you're going to use the next one, which is what is left. So it's obvious, it's logical what's left, right? So you're going to have this one. It is going to be axby minus bxay. Okay, make sure you remember that in the first one you're going to have this negative, and in the second one you're going to have positive, and the final answer will obviously depend on these. Okay, so if here you're getting a negative value altogether, if here you get a negative value, it means negative with negative will become positive. Okay, here if you have a negative value, so it's going to be negative and positive becomes negative. Okay, so that's how you're going to solve it. So basically what you need to remember is the component formula. Okay, again here we are having two formulas. We have one which is using the angle and the other which is using the components. Okay, so let's suppose if a question is given to you where you have components given, so you use the components formula, and they're also asking you to find the basically they're asking you to find the angle between them. So first use this formula, then find magnitude in this, and then finally you can find the angle. Okay, so using this formula you will get A cross B. Then for A you will find the magnitude, for B you will find the magnitude. Then since you have this and since you have these two, so it's easy for you to find theta. Okay, so that's how you will solve it. All right, now we are going to see the properties. As in the previous one we saw the properties for dot product, all very important properties. These might be asked in MCQs and also will be used in the exercises. Okay, so now we are going to see what are the properties of cross product. Number one, anti-commutative. So remember, the dot product was commutative, cross product is not commutative, it's anti-commutative. That is, A cross B is not equal to B cross A cross B is equal to minus of B cross A. Okay, that is what it means by what is meant by anti-commutative. Okay, then we have distributive over addition. Remember that, not multiplication, it's distributive over addition. A cross B plus C is equal to A cross B plus A cross C. Then it is not associative, again, which you have to remember, that A cross B cross C is not equal to A cross B cross C. So first it's anti-commutative, then it's distributive over addition, then it is not associative. Okay, fourth, if vectors are parallel or collinear, that is, by parallel we mean that either angle would be 0 or 180, means either they're lying on the same, that is the points are on the same line, and then the vectors drawn will be obviously on one single line, so therefore they're parallel, or they could be collinear. So this means that the angle is either 0 degrees or 180 degrees, then A cross B is equal to 0, because sine 0 is 0, right? That is why A cross B will become 0, or in case of 180 also it's the same thing. Okay, magnitude. Okay, and also remember that in the dot product, if vectors were perpendicular, then the dot product is 0, that is, the angle is 90. In case of cross product, if the vectors are parallel or collinear, then the cross product will be 0. Magnitude is again magnitude of A cross B is equal to magnitude of A into magnitude of B into sine theta. So here you will not be having the unit vector n, because we're talking about magnitude, we're not talking about the direction. So therefore, to find the magnitude, you just remove n. Okay, because this will give us the answer as a scalar thing. Okay, and if you are just finding A cross B, then of course you will have a unit vector here as well. Okay. Now the geometrical interpretation. The magnitude of the cross product is basically what is, when we talk about a cross product and we take the magnitude as we saw in the previous slide, okay, it is basically equal to the area of a parallelogram formed by A and B. So if you have a parallelogram and its area is what you need to find, it's exactly equal to what the magnitude of the cross product of two vectors. Okay, this is what it is meant. Now in the future video where we will be talking about scalar triple product, we will be seeing the 3D of a parallelogram, okay, in which there is a formula which is basically used to find the area of that parallel piped. So here we are talking about the 2D, which is a parallelogram, and the magnitude of the cross product is basically the area of this parallelogram formed by A cross B. Okay, so now we talk about the direction. This was about the magnitude. Now we have the direction, because why are we talking about this? Because basically A vector has two things. It has a magnitude and it has direction. Okay, so first we talked about the magnitude, now we talk about the direction. So it is perpendicular, the direction, which is, what is the direction? Basically it's n, that is the unit vector n, right? So it is perpendicular to the plane containing a and b, right? So the plane, for example, if you have a sheet of paper and you draw a and b, vector a and vector b on that sheet of paper, then an arrow which is coming going up, right, that was going to be perpendicular to both those a and b drawn on that sheet of paper, right? That is the unit vector, right? That direction is basically perpendicular to the plane containing a and b. That's how you can imagine it. Okay, determined using the right hand rule. So point your fingers in the direction of a, curl them towards b, and your thumb points in the direction of the cross product. So you have vector a, you have vector b, right? And you basically, if I will draw it here, so your vector a is like this. Let's suppose this is a, and then you have vector b here, right? Now you have to do what? You have to curl your fingers in the direction of a, so like this, and then you have to curl them towards b, right? In that way, where is your thumb pointing? Upwards, like this, right? Like this one, right? So this means that this is the direction where the thumb is pointing is the direction of the unit vector. Okay, now if you're just imagining it on a paper, then obviously you will say that it's always going to be up, right? But it depends on the coordinates. Okay, so that comes that comes handy. This right hand rule will come handy when we're talking about different examples and different complex questions. Okay, so here just to explain, this is how it's found. Okay, so you have to point your fingers in the direction of A and curl them towards B, and the thumb will point in the direction of the cross product. Okay, its application, now in the previous scalar product we talked about the applications in work done and projection of A on B. Here we have more extreme, more wider scope for cross product. So it's basically, we talk about torque. So how do you find torque? Torque is a vector and its formula is R cross F. So these are also two vectors. R is a position vector from axis to the point of force, and F is the applied force. Torque is a rotational force, and the unit for torque is Newton meter. So position vector obviously is meter and force is Newton. So the unit for torque is going to be Newton meter. This is where you use a cross product, because we're doing multiplication of two vectors, and the answer is also a vector. Okay. Then for area of parallelogram, again, just in the previous slide we saw that if you have two vectors A and B, then area of parallelogram forming adjacent sides means the origin is same. Okay, so area is going to be A cross B, magnitude of this cross product. Then we have angular momentum. Again, the definition is angular momentum L is equal to RP. So R is a position vector and P is the momentum. So you're going to have P is a linear momentum, which is mv. Right, so from this you're going to get the vector, which is angular momentum. Then you have magnetic force on a moving charge, so that is FB, which is a moving charge. Force on the moving charge is equal to charge, that's Q cross into V, which is velocity, is again a vector, cross B, which is magnetic field, also a vector quantity. So the cross product of two vectors gives a vector. Okay, these are the applications of this cross product. Now we're going to talk about some exercises. All right, so first one, compute the cross product. You have been given two vectors. You use the components, right? First make the determinant, that is ijk, then 1, 2, and in place of k you'll have 0, then 3, 4, and in place of k you're going to have 0. Now using this formula, that is, first you talk about these. Okay, so 2 zeros are 0, 2 4s are 0, hence you get this. Okay, minus, then you're going to take this 1 3 and 0 0, right? So 1 zeros are 0, 3 zeros are 0, j, this is what you get. I'll use a different color. So then you put a plus, then this one. So 1 4s are 4, 3 2s are 6. So you're going to have 1 into 4 minus 2 into 3, right? K. So finally, what will be your answer? 4 minus 6, which is minus 2. So this goes 0, this goes 0, you're left with minus 2k. Okay, that's how you're gonna solve this. Next, question number 2, find the cross product. Again, two vectors are given to you. You have to find the cross product. Similarly, you will make the determinant, and exactly how I explained here, use the formula, and there you go. Okay. Then we have find the magnitude of A cross B. So again, we know the formula for magnitude. We have A is I plus j, that is 1i plus 1j, and B is 1i minus 1j. So we don't have anything for k, so 0, 0. First make the determinant, then use the formula. You get A cross B, you will get minus 2k. Okay, using the formula. Then take the magnitude. So magnitude is what? What is the magnitude here? We know that minus 2, you have to use the formula for magnitude. What is the formula for magnitude? We saw in the one of the previous slides, right? That is magnitude of A into magnitude of B into sine theta. Okay, so that's how you're going to find this magnitude. Okay. Okay, so now we have question number 4. Vector A, magnitude of vector A is given, which is 5. Then magnitude of vector B is given 6, and theta is given 30. First, you have to find the magnitude of A cross B. So that is again using the same formula, 5 magnitude of A into magnitude of B into sine theta. So you will have 5 into 6 into sine 30, and that's how you will find the value of magnitude of A cross B. Next, you have to find a unit vector that's perpendicular to both, right? So to find the unit vector, we know that we have to use a right hand rule. But for that, we need to know vector A, we need to know vector B, and then we use the right hand rule, that is you curl the fingers from A to B and the thumb will point in the direction of the unit vector. But for that we need to have those vectors, right? Since we don't have those vectors, the components are not given to us, therefore we are going to assume the direction using the right hand rule. Instead of giving the exact direction, we are going to assume that direction, right? So we say that the direction of A cross B is perpendicular to both. So in that case, if we say that A and B are on the xy plane, right? If A and B are on the x and y axis, on the xy plane, that is in the 2D plane, the example that I gave of a sheet of paper, that if you keep a sheet of paper on this on the table and then you draw vector A and B on them, so they are in the xy plane, right? They are 2D. So if that's the case, then the thumb is pointing in the upward direction, right? So it's along the z axis, that is now it becomes in the 3D direction, right? So that is why we say that the unit vector n is going to be k, right? Because if A and B lie on the 2D system, then the unit vector is in 3D. Okay, so because it goes perpendicular, it comes out of the paper. Okay, that's how you can understand that A and B are on the paper, so the unit vector comes out of the paper upwards. Okay, so therefore n is equal to k. Question number 5, given A is equal to 4i minus j plus 2k and B is equal to minus 2i plus 3j plus k. Now what you have to do, first find the cross product. So make the determinant I, j, k, and then this is how you make the determinant. So this is the components of A and the components of B, right? So use the formula. We know the formula, that is first this part, then this and this. So basically first jk, then also you can, another way of remembering this is when you're talking about I, okay, you're using j and k components. When you're talking about j, you're using I and k components, and when you're talking about k, you're using I and j components. Okay, that's an easier way to remember. So use that formula and then you get the cross product. Okay, next, area of a parallelogram. If the question asks you find the cross product and the magnitude of the cross product, you use the formulas, right? For example, they might ask you find the area of the parallelogram with the help of these two vectors. So it's the exact same thing. They're just changing the words. They're asking you to find the cross product, find the magnitude of the cross product, but this entire process is also called finding the area of a parallelogram. So it's exactly the same thing. Okay, so you find the cross product first and then use the area of a parallelogram formula, which is exactly the magnitude of the cross product. Do the same thing, that is root of minus 7 the whole square plus minus 8 the whole square plus 10 square, because basically what is A cross B? It's the resultant. A cross B is a vector. Okay, we just have a vector here, and you have to use the same formula of finding the magnitude of a vector, which is under root of A square plus B square plus C square. right? So use that formula, and therefore you're going to get the magnitude of this cross product, which is basically the area of a parallelogram. Okay. Then number 6, we have torque. So this is one of the application, the first application that I told you. So you've been given a position vector, which is 3i plus 4j plus 0k, of course, and you have been given a force which is applied 5i plus 2j plus 0k newtons. Okay, so torque is what? L is equal to Rf. So first we make the determinant and then use the same formula for the cross product, and you will get the answer, which is minus 14k Newton meter. Remember the unit. So torque is L. Also make sure to first write the formula here, okay, because that's how you're getting to this part, right? And then also you're getting to this part, because you have to prove, first you have to show the formula, what is the formula that you're using, okay? Then come to the determinant and then come to this part. So therefore L is equal to this thing, okay, which is 14k Newton minus 14k Newton meter. Okay, sorry, not L, I've been using L, basically use a symbol of torque. Okay, then we have angular momentum, also the next application. So you have position vector here, then you have m, which is the displacement, and you have velocity. Okay, so why are we having m? Because we have to use the linear momentum. Linear momentum is what? P is equal to mv. That is a scalar multiplied with a vector. Again, for this I have done one video in which I have explained scalar multiplication. So in that you can see that basically a scalar, which is m here, which is 2, is going to be multiplied with this vector. So you're just going to multiply with each component, okay, and then that's how you will get the vector for P. So that's the linear momentum. For finding angular momentum, we need a position vector and we need the linear momentum. Okay, so this is given to you, this part, and this is what you will solve first. So first find the linear momentum and then use the cross product to find L. So you make the determinant, use the formula, and that's where you'll get the answer for angular momentum. Okay, also make sure to use the units. Okay. So this is angular momentum. Again, we have magnetic force, also another application. So we have here V, which is velocity. We have B, which is magnetic field, and we have Q, which is the charge, right? So first you have to find QV. What is QV? QV is scalar multiplication, right? So Q is 1, therefore V is going to be, QV is also going to be V, right? 1 into V is V. So you get directly to the cross product. Make sure you write that step first here so that the examiner is made clear what you're talking about. Okay, you don't directly jump to the next step. First make that step clear and then move to the next step. So make the determinant, use the formula, and there you go. So you have the magnetic force as 1i minus 2j plus 6k. Right, so that's all for this video. I hope you liked it. Make sure to like, share, and subscribe to my channel. If you have any questions, type them down in the comment box below. Next up, we're going to talk about scalar triple product. Now, and a question has come from scalar triple product in one of the past papers for CSS Applied Mathematics. So that's also going to be solved in the next video. Till then, stay tuned and wait for the next video. Take care. Bye bye.